Hello students, in my previous videos I have solved 2020 and 2021 mathematics question papers of MBOSE, and today I am going to solve 2022 maths paper. First question from section A, it is given that express the decimal 11.225 as a rational number. So 11.225 can be written as 11225 divided by 1000. After decimal there are 3 places, so it will be 1000. If I cancel both the numbers by 5, then I am going to get 2245 by 200. Again, if I cancel by 5, then it will be 449 by 40, which cannot be further cancelled. So the required answer is 449 by 40. Question number 2. What is the degree of a biquadratic polynomial? We know when degree is 1, we call it linear. When degree is 2, it is called quadratic. If it is 3, it is called cubic, and if it is 4, it is called biquadratic. Therefore, in case of biquadratic polynomial, degree is 4. In question number 3, it is given, find the first term and the common difference d of the AP 45, 50, 55, 60. Here, first term is a, that is 45, and common difference will be second term minus first term. Here, second term is 50, first term is 45. If we subtract, we will get 5. Therefore, first term is 45 and common difference is 5. Question number 4. When are the two triangles said to be similar? Two triangles are said to be similar under these conditions if corresponding angles are equal and corresponding sides are proportional. In question number 5, it is given, find the value of sine of 10 by cos of 80. Sine of 10 cos of 80, here out of these two, numerator or denominator, anyone we have to change, and we have to make the same trigonometric ratio. Here sine of theta can be written as cos of 90 minus theta. Then we are not changing the denominator, it will remain as it is. So instead of sine 10, we have written cos 90 minus 10 by cos of 80, which will give cos of 80 by cos of 80, which can be cancelled. So answer is 1. Question number 6. How many tangents can be drawn to a circle from a point outside the circle? We know from a point outside the circle 2 tangents can be drawn. So answer is 2 tangents. In question number 7, it is given that write the formula for the area of a sector of angle theta of a circle of radius r units. Since radius is r and angle is theta, so area of the sector will be pi r square theta by 360. Question number 8, it is given, find the class mark of the class 35 to 55. So this class interval is 35 to 55 and we have to find the class mark. To find the class mark, we have to add lower limit with the upper limit and we have to divide by 2. So 35 plus 55, which will give 90, 90 by 2, it will give 45. So class mark of the given class is 45. In section B, first question, here it is given that find the discriminant of the quadratic equation 2x square minus 16x plus 30 equal to 0, and hence write the nature of its roots. Here the equation is 2x square minus 16x plus 30 equals to 0. If I compare with ax square plus bx plus c equal to 0, then a will be 2, b will be minus 16 and c will be 30. We have to find the discriminant and formula is b square minus 4ac. So b square, that is minus 16 square minus 4 into a is 2 and c is 30. 16 square is 256 minus 4 to the 8, 3 8 is 24, which will give 240. If I subtract, it will be 16. Since discriminant is greater than 0, therefore roots are real and distinct. Question number 10, it is given, if a is 30 degree and b is 60 degree, verify that sin a plus b is sin a cos b plus cos a sin b. Here a is 30 degree, b is 60 degree. First of all, we are calculating left hand side, which is sin of a plus b. Here a is 30, b is 60, so it will be sin of 30 plus 60, which will give 90, and sin 90 is 1. Again, right hand side, it is sin a cos b plus cos a sin b. Sin of a is 30, cos of b, cos of 60, plus cos of a is 30, b is 60. We know sin 30 is half, into cos 60 is also half, cos 30 is root 3 by 2, and sin 60 is root 3 by 2. Now if we multiply 1 into 1, 1, 2 to the 4, plus root 3 into root 3, 3, 2 into 2, 4. If I take the LCM, it will be 4. 4 divided by 4 1, 1 1 ja 1, plus 4 divided by 4 1, 3 1 ja 3, 3 plus 1 4. So 4 by 4 will give 1. In left hand side we got 1, in the right hand side also we got 1, therefore LHS equal to RHS. In question number 11 it is given that find the value of x where x lies between 0 to 90 degree, and it is given that 2 sine of 2 ICX is root over 3. Here 2 sine of 2 ICX is root 3. So sine of 2x is root 3 divided by 2. Now sine of 2 ICX is sine of root 3 by 2 is sine of 60. So 2 ICX equal to 60. X equal to 60 by 2. Therefore x equal to 30 degree. Therefore required value of x is 30 degree. In the second part, that is odd section, it is given in triangle ABC right angled at A, if AB equal to 4, AC equal to 3 and BC equal to 5, then find cos of B and cosec B. So here in this triangle it is given that in triangle ABC, angle A is 90 degree given in the question, and we have to find cos of B and cosec B. As given, AB equal to 4 cm, AC equal to 3 cm and BC equal to 5 cm. We know cos theta is curly brown here, that is base by hypotenuse. Here it is 4, here it is 5, it will be 4 by 5. In case of cosec B, which is opposite of sine, we know sine theta is some people have. So in case of cosec, it will be hypotenuse by perpendicular, so it will be 5 by 3. So cosec B is 5 by 3. In question number 12, it is given that find the distance between the pair of points 5, 8 and minus 3, 2. Here first point is given 5, 8 and second point is minus 3, 2. By using distance formula, distance will be root over x2 minus x1 whole square plus y2 minus y1 whole square. x2 minus x1, that is minus 3 minus 5 whole square plus 2 minus 8 whole square. Minus 3 minus 5 will give minus 8 square plus 2 minus 8 is minus 6 square. 8 square is 64. 6 square is 36. After adding it will be 100, and root over 100 is 10. Therefore distance between the given points is 10 units. In question number 13 it is given find the coordinates of the centroid of the triangle whose vertices are minus 3, 0, 5, minus 2 and minus 8, 5. Here first point is minus 3, 0, second point is 5, minus 2 and third point is minus 8, 5. By using centroid formula, coordinate of the centroid will be x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So minus 3 plus 5 minus 8 divided by 3. 8 and 3, if I add it will be 11. 5 minus 11 will be minus 6 by 3. Here 5 minus 2, 3, 3 by 3. 6 by 3, it will give minus 2, 3 by 3, 1. Therefore required coordinate is minus 2, 1. 13 odd part, it is given that find the ratio in which the point 2, y divides the line segment joining the points A minus 2, 2 and B 3, 7. Here it is given that 2, y is a point on the line joining A minus 2, 2 and B 3, 7. We have to find the ratio in which it divides. So let the ratio be k is to 1. We can write let the required ratio be k is to 1. So by section formula, if you consider the first point, that is 2 equals to k into 3 plus 1 into minus 2 divided by k plus 1. This is called section formula. We are considering only the abscissa part. Y part we are not writing because it is not required. So 2 equals to k into 3 plus 1 into minus 2 divided by k plus 1. So 2 into k twice k, 2 into 1 2 equals to 3k plus minus minus 2 1 ja 2. So 2k minus 3k minus 2 minus 2. So minus k equal to minus 4. So k equal to 4. Therefore required ratio is 4 is to 1. Question number 14. The triangles ABC and DEF are similar if the area of triangle ABC is 9 cm square and area of triangle DEF is 64 cm square and DE is 5.1 cm. We have to find the length of AB. Here it is given triangle ABC is similar to DEF. Since triangles are similar, so we can use area theorem. So area of first triangle by area of second triangle equals to AB square by DE square. Here it is given area of triangle ABC is 9, DEF is 64 equals to AB square by DE square is 5.1 whole square. 9 can be written as 3 square, 64 can be written as 8 square equal to AB by 5.1 whole square. If I take square root on both sides, it will be 3 by 8 equals to AB by 5.1. If I cross multiply, it will be 8AB equal to 3 into 5.1. So AB equals to 3 into 5.1 will give 15.3 by 8. After dividing, it will give 1.9125. Therefore, required length is 1.9125 centimeters. In question number 15, it is given in the given figure, CP and CQ are tangents to a circle with center O. ARB is another tangent touching the circle at R. If CP is 11 centimeter, BC is 7 centimeter, then we have to find the length of BR. In this sum, this length is 11 centimeter, this part is 7 centimeter, and we have to calculate BR. Now we know lengths of tangents drawn from an external point to a circle are equal. So PC will be equal to QC. If PC is 11, QC also will be 11. BR and BQ also will be equal. Here we have to find BR, and BR equals to QB, and QB is QC minus BC. So we can write here BR equals to BQ and BQ equals to QC minus BC. Since QC equal to PC, so instead of QC, we can write PC minus BC. Now PC, as given in the question, PC is 11 and BC is 7. So it will be 11 minus 7, that will give 4 centimeter. Therefore, required length of BR is 4 centimeter. This way also you can do, but this will be little bit lengthy. Better to do this way. In 15 first part, it is given one and only one tangent can be drawn through a point lying on the circle. This is given in the book also. So this statement is true. So here answer is true. In the second part of 15, can we draw infinite number of tangents to a circle? Yes. At all the points in the circumference we can draw tangents. So the second statement is also correct. In section C, first question is a construction which I have given in my videos on construction. So you can just do it from those videos. Now question number 16. Here first question is all equilateral triangle. All equilateral triangles are similar. So answer will be first part similar. Second part, the lengths of tangents drawn from an external point to a circle are equal. Yes, this is the statement of theorem 2 of chapter 10. So statement is true. Third case, find the radius of a circle whose diameter is 35 centimeter. So here diameter is given 35 centimeter and diameter is twice of radius. So twice of radius is 35. So radius is 35 by 2, which will give 17.5 centimeter. In question number 17, it is given in the adjoining figure, triangle ABC is circumscribing a circle. Find the length of BC. In this case, ABC is circumscribing this circle. This is 4 centimeter, 3 centimeter. This whole length is 11, and we have to find the length of BC. Now we know that lengths of tangents drawn from an external point to a circle are equal. So AR will be equal to AQ. Both will be equal to 4 centimeter. BR equal to BP, both will be 3 centimeter, and QC equals to PC. These lengths are not given. Now we have to find BC. BC means BP plus PC, so we can write BC equals to BP plus PC. Now we know BP equals to BR. Instead of BP, write BR. PC is equal to QC. Instead of PC, write QC. Now BR already you know it is 3 centimeter, so it is 3 plus what is QC? QC is AC minus AQ, so we can write AC minus AQ. AC is 11, so it will be 11 minus AR. So 3 plus 11 is 14 minus AR. AR given in the question 4, so it will be 4. 14 minus 4, 10. Therefore required length of BC is 10 centimeter. In the second part, it is given in the given figure, triangle OAB and OCD are similar triangles. Here it is given AB is 8 centimeter, BO is 6.4 centimeter, OC is 3.5 centimeter, CD is 5 centimeter. We have to find the length of OA. So since triangles are similar, then sides will be proportional. So here these two triangles are similar. OAB and OCD are similar triangles. So it will be OA by OC, AB by CD, OB by OD. Now, since we need these two, so we are not writing this part. So OA is given in the question. OA we have to find. OC given in the question 3.5. AB given in the question 8, and CD given in the question 5 centimeter. Just because this part is not required, so we are not writing in the next line. So OA equals to 8 into 3.5 by 5. 3.5 if you cancel by 5, it will be 0.7, because 5 7 are 35, it will be 0.7. 8 into 0.7 will give 5.6 centimeter. Therefore required length of OA is 5.6 centimeters. In question 17a, which is for blind students, it is given that if the corresponding sides of two triangles are equal, then they are similar. State true or false. When the corresponding sides of two triangles are equal, then they are both congruent and similar. Therefore, the answer is true. The distance between two parallel tangents to a circle of radius 6 cm. Since distance between two parallel tangents, it will be like this. This is one tangent, this is another tangent. Radius is given 6. So distance between the tangents will be diameter. So 6 plus 6, it will be 12. So distance is 2 into r, which will give 2 6 ja 12 centimeter. Therefore distance between the parallel tangents is 12 centimeters. In question number 18, it is given that a sheet of paper is in the form of a rectangle ABCD, in which AB is 40 centimeter, AD is 28 centimeter. A semicircular portion with ADS diameter is cut off. Find the area of the remaining part. So here length is given 40 centimeter, breadth is 28. So in rectangle ABCD, length is 40, breadth is 28. In case of semicircular portion, diameter is 28. So radius will be half of diameter, that is 14. So area of the remaining part will be area of the rectangle minus area of the semicircle. We know area of a rectangle is length into breadth, and area of the semicircle is pi r square by 2. So we can write area of the remaining part is area of ABCD minus area of semicircle. Rectangle length into breadth minus half pi r square. Pi r square is the area of a circle. For semicircle, you have to divide by 2. If I multiply 1120 minus half into pi is 22 by 7 into 14 into 14. 7 2 ja 14. So 1120 minus 308. If I multiply 22 and 14, it will give 308. After subtracting, it will give 812. Therefore 812 centimeter square is the required area of the remaining part. In the odd part, it is given that find the perimeter of a sector. Find the perimeter of a sector of angle 45 degree of a circle with radius 7 centimeter. Suppose this is the sector, and if you want to find the perimeter, perimeter means boundary. This is radius, this is also radius, and this part is the arc. We know the perimeter of the sector formula is r plus r twice r, and this arc length. Now arc length formula is pi r theta by 180. So it will be twice r, that is 2 into 7, plus pi r theta, pi, that is 22 by 7, r theta, r is 7, theta is 45 by 180, 45 4 ja 180, 7 7 cancel. So we are left with 7 2 ja 14 plus 22 by 4. After cancellation by 2, it will be 11 by 2. 14 plus 11 by 2 means 5.5. After adding, it will give 19.5 centimeter. Therefore, required perimeter of the sector is 19.5 centimeters. Number 19, it is given a die is thrown once. Find the probability of getting an even number, a number less than 5. So when a die is thrown once, then the possible outcomes are 1, 2, 3, 4, 5, 6. So there are 6 possibilities. So we can write number of possible outcomes 6. Now the first part, it is given even number. Even number in this sample space are 2, 4 and 6, because these 3 numbers are divisible by 2. So here even numbers are 2, 4, 6. Therefore number of favorable outcomes equals to 3. Therefore probability of an even number is number of favorable outcomes by total number of possible outcomes, that is 3 by 6. If I cancel by 3, it will be 1 by 2. The second case, it is given numbers less than 5. Number less than 5 in this sample space are 1, 2, 3 and 4. So there are 4 favorable outcomes. Therefore probability of less than 5 will be 4 by 6. If I cancel by 2, it will be 2 by 3. In question number 20, it is given that find the HCF of 924 and 714 by Euclid's division algorithm. So if I divide 924 by 714, because this is the bigger number, 714 1 just 714. If I subtract 210, now you bring 714 here. This one into 3 will give 630. It will be 84. Now you divide 210 by 84. It will be 168. Remainder is 42. Now you divide 84 by 42. We will get remainder 0. And we have to continue till we get remainder 0. So we can write by Euclid's division algorithm, 924 is 714 into 1 plus 210. 714 can be written as 210 into 3 plus 84. Then 210 can be written as 84 into 2 plus 42. And 84 can be written as 42 into 2 plus 0. So this way you write, since in the last step when remainder is 0 we have divided by 42, therefore required HCF is 42. In OR part of 20 it is given, find the HCF and LCM of the pair of integers 26 and 91 by prime factorization method and verify that HCF into LCM is the product of the two numbers. So here numbers are 26 and 91. 26 if we prime factorize it will give 2 into 13, and 91 if we prime factorize it will give 7 into 13. If you want you can show like this, 26 with 2 it will be 13, and 91 with 2 it is not divisible, with 7 it is 7 13 ja. Now HCF of these two numbers, since 13 is the common number, so HCF is 13. In case of LCM we have to write all the factors with their maximum power. Here factors are 2, 7 and 13. 2, 7, 13. If I multiply it will be 182. So HCF is 13, LCM is 182. Now for verification, first of all we have to multiply HCF into LCM. If I multiply 13 and 182 it will give 2366. And if we multiply the numbers, product of the numbers, here also we got 2366. Therefore HCF into LCM is the product of the numbers. In question number 21 it is given that if 10 of the polynomial a square plus 9x square plus 15x plus 6a is reciprocal of the other, then find the value of a. Here it is given that polynomial is a square plus 9x square plus 15x plus 6a, and as it is given that 10 of the polynomial is reciprocal of the other, so if you consider 10 as alpha, then we have to take another 1 by alpha. Now since here coefficient of x square and constant term, these two terms are invoked, so we are using the formula product of zeros. So product of zeros formula is constant term by coefficient of x square. Product of zeros will be alpha into 1 by alpha equal to constant term. Constant term is here 6a and coefficient of x square is a square plus 9. Alpha and alpha can be cancelled. If you cross multiply, a square plus 9 equal to 6a. If I transfer this 6a, it will be a square minus 6a plus 9 equals to 0. This can be written as a square minus twice ab plus b square, because 9 is 3 square. So a square minus twice ab plus b square, which is the formula of a minus b whole square. So since a minus 3 whole square is 0, that means a minus 3 also 0. And since a minus 3 0, therefore a equals to 3. Therefore required value of a is 3. In question number 22 it is given that is 310 a term of the AP 3, 8, 13 and 18. Here it is given that 3, 8, 13, 18. Here 3, 8, 13 and 18 are first 4 terms of the AP. Here first term is 3. Common difference is 8 minus 3, that is 5. We have to check whether 310 is a term of the AP or not. So suppose a and b 310. So we can consider an is 310. We know the let nth term is 310. So nth term is a plus n minus 1 into d is 310. So a is 3. So 3 plus n minus 1 into d. D we know it is 5 is 310. So n minus 1 into 5 is 310 minus 3. So n minus 1 will be 310 minus 3 will give 307 by 5. So n equal to 307 by 5 plus 1. So n equals to, here you take 5 as the LCM. 5 divided by 5 1, it will be 307 plus 5 into 1 5. So n equal to 312 by n. N is the number of term and it cannot be in fraction. Since 312 by 5 is not a counting number, therefore 310 is not a term of the given AP. In question number 22 second part, it is given that the nth term of a sequence is twice n plus 3. Is the sequence an AP? If so, find its sixth term. Here nth term is twice n plus 3. So the next term, that is n plus 1th term, will be twice n plus 1 plus 3, which can be written as 2n plus 2 1 is 2 plus 3. Therefore, twice n plus 3 plus 2, 5. Now, difference of these two, an plus 1 minus an equals to 2n plus 5 minus 2n plus 3, which can be written as twice n plus 5 minus twice n plus minus 3 plus twice n minus twice n can be cancelled. So, 5 minus 3, 2. Since it is independent of n, therefore it is an AP. Now it is given find the sixth term. Therefore, sixth term will be A6 will be 2 into 6 plus 3. 6 to the 12. 12 plus 3, 15. Therefore, sixth term of the AP is 15. In question number 23, it is given that prove that 1 plus sin theta by 1 minus sin theta equal to sec theta plus tan theta whole square. In the left hand side, it is given 1 plus sin theta by 1 minus sin theta. Here, if we multiply both numerator and denominator by 1 plus sin theta, then I am going to get 1 plus sin theta into 1 plus sin, and here it will be 1 minus sin into 1 plus sin. In the numerator, it is 1 plus sin theta whole square, and here a plus b, a minus b, a square minus b square. So 1 plus sin theta whole square. 1 square minus sin square will give cos square theta. This can be written as 1 plus sin theta by cos theta whole square. Now 1 by cos theta plus sin theta by cos theta whole square. 1 by cos theta is sec theta and sin theta by cos theta is tan theta. So we got sec theta plus tan theta whole square, which is the required right hand side. In the second part, it is given that if x cosec theta equal to a and y cot theta equals to b, prove that a square by x square minus b square by y square equal to 1. Here it is given that x cosec theta equals to a and y cot theta equal to b. And we have to show that a square by x square minus b square by y square equal to 1. So we are starting from the left hand side. A square, a is x cosec theta, so it will be x square cosec square theta by x square minus b square, b is y cot theta, so b square will be y square cot square theta by y square. This x square can be cancelled, this y square can be cancelled, so it will be cosec square theta minus cot square theta, and we know cosec square theta minus cot square theta is 1, so we got 1, which is the required right hand side. In the next question, that is question number 24, it is given that 6 years hence a man's age will be 3 times as old as his son, and 3 years ago he was 9 times as old as his son. Find their present ages. So here we are considering, let man's present age be x years and son's present age be y years. So after 6 years, man's age will be x plus 6 and son's age will be y plus 6. Now in the first part of the question, it is given that 6 years hence a man's age will be 3 times the age of his son. So man's age will be x plus 6. So man's age, that is x plus 6, equal to 3 times son's age, that is y plus 6. So x plus 6 is 3y plus 3 6 is 18. So x equal to 3y plus 18 minus 6 will be 12. So x equal to 3y plus 12 is the equation number 1. Again it is given that 3 years ago father was 9 times as old as his son. So 3 years ago man's age was x minus 3, son's age was y minus 3, and according to the question man's age was 9 times the age of his son. So x minus 3 is 9y minus 27. So x is 9y minus 27 plus 3. So x is 9y minus 27 plus 3 is minus 24. So here also we got x equal to 3y plus 12 as x, and here we got x equal to 9y minus 24. From 1 and 2 we can equate 3y plus 12 will be 9y minus 24 because both are equal to x. So 3y plus 12 equal to 9y minus 24. If I transfer all the y in the same side, 3y minus 9y minus 24 minus 12. So 3 minus 9 will be minus 6y is minus 36. So y will be 36 by 6, 6 years. So we got y 6. Now if you put this one in equation number 1, that is x equal to 3y plus 12. So from 1 x equals to 3 into 6 plus 12. 3 6 is 18 plus 12 30. Therefore man's present age is 30 years and son's present age is 6 years. In second part of question number 24, it is given that find two consecutive positive integer, the sum of whose squares is 365. Here we can consider the positive integers be x and x plus 1. When we say consecutive, so if one number is x, next one will be x plus 1. According to the question, sum of the squares, so x square plus x plus 1 whole square, this will be 365. So x square plus x plus 1 whole square is x square plus twice ab plus b square. So it will be x square plus twice x into 1 plus 1 equal to 365. X square plus x square 2x square plus twice x plus 1 minus 365 will give minus 364 equals to 0. From here if I take 2 common, it will be x square plus x minus 182 equals to 0. So x square plus x minus 182 equals to, if I transfer this 2 in the other side, it will be 0 by 2, it will be 0. Now 1 into minus 128 is minus 128. So we can write 182 as 14 and 13 because 14 minus 13 is 1. So x square plus 14 minus 13x minus 182 equals to 0. X square plus 14x minus 13x minus 182 0. From here x common, x plus 14. From here minus 13 common, x plus 14 equals to 0. So it will be x plus 14, x minus 13 equals to 0. So either x plus 14 is 0 or x minus 13 0. Here we got x equal to minus 14 and here x is 13. But in the question it is given positive integer. Since it is negative, it is rejected. So x is 13. Therefore first number is 13 and second one will be 13 plus 1 14. So we can write required integers are 13 and 14. In 25 second part, it is given the length of a string between a kite and a point on the ground is 90 meters. If the string makes an angle theta with the ground level such that tan theta equals to root 3, how high is the kite? Assume that there is no slack in the string and we have to use root 3 as 1.732. Here, suppose A is the position of the kite and AC be the string. Here it is given ACB is theta and AC is 90 meter. We have to calculate the height of the kite, that is AB. In this question it is given that tan theta is root 3. Since tan theta is root 3, that means tan theta is tan of 60. So theta equal to 60. Therefore this angle is 60 degree. Now we know the angle, we know hypotenuse and we have to calculate perpendicular. So we have to use sin theta because some people have. So we are writing in right triangle ABC sin theta AB by AC, sin of 60 AB by 90. Sin 60 is root 3 by 2, AB by 90. If I cross multiply twice, AB is 90 root 3. AB is 90 into 1.732 as given in the question root 3. We cannot change the value. 90 by 2 will give 45 into 1.732. After multiplying it will give 77.94 meter. Therefore height of the kite is 77.94 meter. In 25, which is for the blind students, question number A is prove that 1 minus sin square theta into sec square theta is 1. We can write here 1 minus sin square theta as cos square theta because we know sin square theta plus cos square theta is 1. So 1 minus sin square is cos square theta into sec square theta. Now cos square theta into sec square is 1 by cos square. This cos square theta and cos square theta can be cancelled. So it is 1, which is the right hand side. Second part is, in question number B, it is given the value of sec 60 is half. We know sec 60 is 2. Therefore, the given statement is false. Part C, it is given cos of 90 minus theta. We know cos of 90 minus theta is sin theta. So here answer will be sin theta. So we have done up to 25. That's all for today. In the next session, I am going to start from question number 26. Thanks for watching.